My name is Waliu Ayuba. I'll be talking about medical AI assistant using Gemma model. Here's my background. I'm currently a master's degree data science student at Northeastern University with a strong statistical foundation. I have over 6 years in analytics, and I'm currently a Google KaggleX Fellow while working on advanced healthcare AI solution. My career focus uh, to develop a production-ready AI system for healthcare, combining the end-to-end medical AI solution and machine learning system optimization. Also, the real-world healthcare applications. Here's my project objective. We develop an interactive medical consultation system that provides preliminary health guidance and the severity assessment. The tech stack used in this project are Streamlit, launching the Google Cloud Vertex AI Gemma 7B LLM, that is pre-trained model. The data science topic applied a large language model where we utilize Gemma 7B for medical response generation. We also implemented prompt engineering for structured medical responses and the change of thought, which is used for context enhancement. The application sector goes this way. We primarily leverage on LLM Gemma 7B chain for structure processing, utility for medical text processing. Here's the dataset structure. We have about 250,000 medical dialogues, which the format consists of patient-doctor conversation. And on the right screen, we have a description column, patient and doctor. The description is to describe the questions of the patient, and the doctor is to respond to the question of the patient. And the method we deployed or we use in this method in this project are called technologies leverage on Gemma 7B LLM with LoRa fine-tune rank 32 on medical dataset and deploy via Google Cloud Vertex AI. We use Streamlit and also implement TED LangChain for structured medical response. The architecture highlight goes this way. We build a comprehensive medical AI system using Gemma 7B that is cost-effective, open source medical LLM, LangChain structured medical response chain. We also consider interactive medical consultation interface where we use a Streamlit and also efficient model adaptation for healthcare where we use LoRa. And then when we consider deployment and we look into scalable cloud deployment where we use a Vertex AI. And the data processing include the utilization of 250,000 patient doctor dialogue for training, implementing medical context enhancement and severity assessment protocol. And why this method? We all know that when we consider memory efficient and model adaptation, we definitely have to look into the LoRa, and then building some sort of user-friendly medical interface, we look into LangChain and Streamlit. And then in terms of reliable cloud infrastructure, we go with Vertex AI. The benefits of using all these methods are resource optimization, then cost effectiveness, and then in terms of product reliability. Then what we learn from this technical mastery, where we develop expertise in LLM deployment using LoRa fine-tuning, LangChain, and Google Cloud Vertex AI, in which we create an efficient medical AI assistant with optimized performance and scalability. We also look into healthcare domain, like trying to build some sort of expertise in domain problem, where we gain a deep understanding of medical response pattern, severity assessment, implementing structured healthcare, communication protocols while ensuring accurate patient-doctor interactions. The professional implementation established robust medical safety protocols, including disclaimers. We also check for validation and quality assurance measures, where we maintain healthcare standard in AI context. Solutions implemented technology in terms of technology innovations. we consider LoRa fine-tuning with structure change patterns and caching mechanisms and achieving efficient model performance while reducing computational overhead. We consider healthcare safety measures as well, where we build some sort of comprehensive medical safety system, including severity classification, where we have some sort of low, medium, and high. So we want to see how severe the symptoms is. In that sense, we're gonna classify it like, is it very high? Is the symptoms very high or low, or in the some sort of medium or medium? Then we consider the context enhancement and validation protocols to ensure reliable healthcare guidance. The system optimization integrated real-time monitoring feedback loops with fallback mechanisms, and where we create a robust and responsive medical AI system. We also look into feature improvement, where we be focusing on expanding model capabilities with larger context windows and multimodal features while implementing advanced caching and automated system for improving system reliability. Like, we also going to consider the alternative version as well, like, to enhance the AI medical knowledge base. We would probably be looking into RAG instead of over fine-tuning. Then the system performance through improved context handling and automated testing, also robust monitoring system. Here's the project example before we fine-tune it. On the screen, we can see that the response wasn't really coherent. It doesn't really give a meaningful context. And yeah, that's what we have there. And after we fine-tune the model, it is more coherent and more understandable than give a meaningful context. We also look into the evaluation of the responses, like how relevant the response is. Then we have about 0.79, and we also consider the response quality, like where we have acknowledgement and assessment. So on the right screen, we have some sort of acknowledgement. Out the responses will definitely gonna acknowledge the patient questions, then assess it, then give some sort of practical recommendations, and also specific warning if it is severe. The rest on the slide, when we talk about severity assessment, we have mentioned like a low, high, or middle or something. So if it is very high, it's gonna post some sort of warning, like maybe you should see a doctor immediately or consult, like that kind of context. It's gonna provide that. And also we have some sort of professional medical languages, where we have a fever, we have medication, we have infection, we have symptoms, all of that. Those are the medical, professional medical language we observe in there. And then the prompt, of course, the prompt of this thing is a patient having headache and a fever. Then the technical performance is 133 tokens used. Then we have 5 follow-up questions and no hallucination detected. We also have an appropriate of empathy level of a 3:5 ratio. The overall assessment is supposed to determine that it is very safe. Professional medical communications is detected, and evidence-based approach. We also have clear safety guidelines in this application. So here's the demo. We'll be running it through terminal command line, and we use this command line to run it. And here's it after being launched, and then here's the command line being run here. We have it there. Then we have the interface that looks like this. I already prompted, and I have this response, like I can sleep. Then you get the acknowledgement and the assessment. Also, the recommendation are this, like establish a regular sleep schedule and stick to it as much as possible. Then create a relaxing bedtime routine that helps you wind down before bed. All of those suggestions. And the warning is if you have persistent insomnia that is impacting your daily life, it may be a sign of an underlying medical condition. So like that's the warning, just like I said in the previous slide. So on this side, where we have the system status, like connections, and to test the connections, and we have the statistics and how many consultations we have. We already have 3 consultations. I've run it like 3 times now. So we have like three consultation, like, and we have a unique concern, and the classification of it is low, like not like severe in terms of severe assessment, like we discussed earlier on. So if I want to prompt it again, like I have a headache and a fever. So we're gonna see it's loading. We're gonna give it a little bit of time to get a response. And just reminds me, it's one of the improvement that the future improvement to optimize the running time. So here's it. So we have it to be this assessment included temperature, hydration status. You got the context of the prompt. Then acknowledge me understand that fever. So like, and then based on the retrieved information, it is possible that your symptoms are due to infection or inflammation. So it suggested that, and then we have some sort of a temperature level. And additionally, recommend that you drink plenty of fluid to stay hydrated and rest as much as possible. That those are the things. It recommended that, and then gives a warning if your fever exceeds this temperature, then suggest like go to severe headache or confusion, or like is go to seek medical attention immediately. So and then follow up if you did not improve for the hours. So that is suggestions. And now we also want to consider what's how relevant is this response from every patient. So we recommend that they should give a feedback. So that's it will help us to improve, and then give us some sort of trend of questions, the most questions asked. So and then how relevant is the response to the question asked. So it's gonna keep our levels to keep track the trend. So we also have the disclaimer that this application does not intend in any way to replace professional medical advice, and we recommend that every patient or the users to only consult a qualified healthcare provider for medical diagnosis and treatment. Here's my project links, and then my personal links goes you can get access to the code on GitHub, and my LinkedIn is here as well. If you want to reach out to me to talk more about it, I'm open to messages, and I can always respond to that. Any query, any questions you have. So the model, the Kaggle model card is I mean we deploy the model on Kaggle, so you can always have access. You want to make a reference to it, you can always use it there. It's public, and there's a project notebook as well on Google Colab Research, so you can also use it if you want to for your reference purpose. Thank you.